MCTBA or any other peroxy acid used the double bonds, you can imagine that epoxidation is what's going to happen. MCTBA just happens to be the one of the epoxy and the peroxy acid that we use frequently because it's very easy to use. So MCTBA will make an epoxide. And then the second step, acidic water, right? What happened was this oxygen is going to get protonated. That's going to pull the density from the carbons. I mean, this molecule is symmetrical, so it doesn't really matter which carbon get attacked, right? But either attacks by the water, because that's a neutral valve there, makes an attack, becomes an OH here. They're going to be same. So it really doesn't matter which one it is. It becomes a diol, but you got to show the trans diol. I need you to show these hydroxyl groups, that hydroxyl groups must be opposite side. One must be wedged, the other has to be dashed. Don't use regular solid line, right? If you're using regular solid line, that means you don't know where they are, other than it's just found there. So you got to show the stereochemistry because it's relevant. So that's what I mean. When it matters, you have to show stereochemistry, and then this opening epoxide and acidic water, you got to show them the trends. I can ask this question a bit different way. Now this one's going to be a level more difficult, right? What you see here, I changed this question by adding one alkyl chain on the one of the double bond carbon. And then what I did is I got same MCTBA, but I have a second step, acidic conditions, not in water, in alcohol. I can also change that alcohol to something else, but anyway, the point is, this is hydroxyl groups. That's hydroxyl groups. So only thing that you probably have to remember that solving that question, you just have to put in trends. That's the only thing that you need to know. But that's not going to be sufficient for this question. So let me show you how that changes here. The first step with an MCTBA, the same this MCTBA making epoxide using the double bond, right? It's going to make an epoxide. You can either put an epoxide oxygen on the top or the bottom. That really doesn't matter. I just put it on the top, but you can decide to put it on the bottom. It doesn't change anything except the stereochemistry, the enantiomers. So, but anyway, I put the epoxide on the top. We put an acidic acid in alcohol, not in water. But acid is the one that protonated oxygen, not alcohol. Once oxygen is protonated, now the oxygen is overly positively charged. It's a very electron deficient. That's going to pull the density from the carbon is bound to. And we got one carbon more substituted than the other carbon. In the previous example, they are symmetrical. So this water molecule, the 50% attack this carbon, 50% attack the other carbon. So it doesn't really matter where it goes. But in this case, because they are differently substituted, the more substituted carbon will get more electron deficient, and that's the one nucleophile, which is an alcohol, going to make an attack. So alkoxide, the methoxide, coming from the methanol, is going to be sitting on the more substituted carbon. Because of the more electron deficiency, is going to be built on the more substituted side after protonation. So this is a backside attack. Epoxide is on the top of the screen. So alcohol has to attack from the behind the screen, anti-addition. So that goes the more substituted side and anti-addition to the hydroxyl groups coming from the epoxide. So they're going to be trends. So trends relationship is the same, but because we have a different nucleophile, which is different from the OH, you're going to see this is going to be methoxide on the more substituted side, OH on the less substituted side. There have to be trends. So there's so many things that you need to think about to get it right. So to solve a question like this, you need to know the mechanism. That's the only way. Just like a mathematical question, if you want to get it right, you have to try the equation, right? You just cannot guess it. You have to try it. Same thing for the organic chemistry. Even though it has a full of exceptions, majority follow the mechanism, so we can actually imagine what would happen. And then it actually works out that way. That's why it becomes science, rather than just random guess. So you got to treat organic chemistry like the mathematics for the physical science. You have to use a mechanism to drive it up. Anyway, so this is the kind of things I want you to know for the, epoxidation and opens it up. But I also want you to know the difference between these two. This one is what we just talked about. Making epoxide and opening acidic condition, then you get the transdiol, as we just discussed. That's basically what we get here. What about that one, right? Osmium tetroxide, hydrogen peroxide, these reagents will put the 2OH, but on the same side. So you get different geometry. So that is something you also want to pay attention. Since diol cannot be made by the epoxide, it has to come from these reagents, osmium tetroxide or the permanganate in cold diol condition. So I want you to use the right reagent for the right occasion. And obviously, you're going to get enantiomers because of the facial selectivities of what we don't expect from the simple reagents. But they're going to be cis. The same thing for that. That's going to, you're going to get the enantiomers too. But in this case, they equivalent, so they actually need the symmetry.